Wow. What do you do about a situation like this? Stop for a while and ponder it. Ponder it. Is there some way I can sneak the power in past whatever the problem is? I don't know. Maybe the schematic might help a lot with this. Okay, let's take a look at the power supply here. What I'm thinking is, it's possible, you know, the power supply transformer shot in this radio, and that's what's happening. It could be an open circuit in the primary here. So let's just, this looks like the primary, 1 and 2. Let's just see if that's the case. So we have many possible primary choices here. Input voltage selector switch. Wow. All these different, look at that, 145, 190, who uses that? But anyway, number 5, that's where it should be for us. When I look at the front of this transformer, it doesn't look anything like this. You can't see all these. You just see these two. You get 1 and 2. You really want to see 1 and, well, let's see, if you're going to run this 90 volts, 110, you would want it to come in on this leg, I guess. But I don't see all these terminals. I don't see how you do this. Where's this switch? If I got this thing completely turned around, and you know what? I think I have it completely turned around. Okay, let's take a look at the transformer here. Wow, look at that, look at that. Just look at that for a minute. So on one side you got 1 and 2, and on the other side you got all the rest. 3, 4, 5, 6, 7. What happened to 8, 9? 8 and 9. Are they at the other end back there? Is there no 8 and 9? Come on, don't fool with me now. Yeah, there's no 8 and 9. You know, just to throw you off. You do that kind of stuff. So there we are. So, okay, I'm cluing in now. I'm cluing in. This is the primary end. This is the secondary part. Okay. And now when I look at it, yes, there's a pile of wires coming off of here, going over to the selector, I guess, which will select which one you want to be on, and the selector in the window says 110. So everything's fine in that respect. Okay, I think I understand what I'm looking at now. Let's go look at the transformer. Whoa, wait a minute, look at some more stuff here. Does it give me the resistance of the primary? Well, not here, but it might somewhere. It might give it right here, for crying out loud. Look at that. So we have some information here we can really use on the primary side if we need it. Okay, let's look at the transformer. So there is something definitely rather odd here. So anyway, here's 1 and 2. This is number 2 here. Look at this weird thing. We're going to take a close look at what this is. It's really weird. And then here's the rest of them. As you can see, these wires heading up towards this feature here, which is the selector for what voltage you want the set to operate on. So that is as it appears, and then the other terminals are back here. Look at this thing. This is just the strangest deal here. What is going on with this? So we'll switch to our close-up camera. Can't say I've ever seen anything like this, or why would it even have it like this. So you see back here, there's a wire attached to a terminal, and there's a metal strip running on what looks like an insulated piece of material that is riveted in the corners. So this metal strip is running along, and when it gets here, it does this. And down below, kind of dirty, is the wire going into the going in. So I think that's one lead, and the other lead is this one. What are they trying to do here? Like, did somebody forget you can just solder wires together? Why is this? What is this? Does this make any sense at all? So it looks like there's a spring tension system here. This is pulling up, I'm guessing. It's pulling up on this. This is a really crazy fuse. So this looks like you could literally, I don't really want to do it, but you could push this down. Yeah. Well, that's no connection. What crazy thing is this? Tell me this is, no, there's a wire soldered to it. I mean, it's not just a strip holding, things together. It's doing something. So it looks like there's a piece of paper underneath the metal. Is this thing even held in there? Look, it's just laying in here. This can't be electrical. Can it? It could certainly be an explanation for why. If this is supposed to be carrying the input power, is there another terminal here? There's only these two terminals like we saw on the, well, they don't look, well, they do kind of look like what they showed on the diagram. This is the weirdest thing going. I mean, everything in my head is saying this can't even be. Nobody would do this. Why would they do this? This is just a kind of a ridiculous arrangement. Why this long band all the way over to here? Really got me. Now, if these are the primary wires, then hitting the switch should put 120 volts. Yeah, right between these two terminals here. Okay, let's check it out. And I guess it would be coming on this wire, so I really need to clip on this wire to start with. And this wire. Yeah. They got a black wire here too. It just gets in that bundle and carries on over yonder. Okay, so here's a couple things we can do here now, because I have a new instrument, and it gives us a chance to do something right here really easily. So over here on this control here, output is set to 0. I'm just going to crank this up a little bit. How's that going to help, Jim? Because we're going to try to find this voltage on these terminals, and I'm not going to try powering a radio right up with 120 volts during this test. There's no need to. So we're looking for the supply voltage on the primary of the transformer. Okay, my meter may be upside down, but I think we can probably figure out what it says still. So we want to go here, and then I want to go back on this wire up here. On the assumption that I don't know what that thing is, so I don't even know what to call it. The thing. We'll call it the thing. On the assumption the thing is not making a contact. Just putting a brake on here. That's too big. Okay, let me get a little better view of the meter here. There. Oh, that's not too good. There we go. So what I want to do is crank up the, first I'm going to crank down the voltage. So there's 0 volts. I'm going to apply voltage to the radio, but there's 0 volts. Still doing it through the light bulb, but that shouldn't matter. I should see 0 volts here, but as I crank up the supply, if I just come back a little bit and do this, I should be able to see. Oh, come on. Yeah. Welcome to the world of camera angles here. Good enough. Good enough. I'm going to reach right across. Okay, so there's just a dribble of voltage here now. Is the set turned on? Let's turn the set off. Let's start with it off. Okay, it's off. Should see nothing here. Turn this up a bit. There we go. See nothing here. Okay, and then we're going to turn it back down. And we're going to turn on the radio here with one button. Okay. This time we should maybe see something come up on the meter. And so we got 10 or 20 volts there and nothing happened here. What's that sound? Oh, look who's come. Look who's come to visit here. Good, I need some help. So did I do this right, even? Did I deduce all this correctly? I really think so. I really think... What else could it be? Could it be... Could it be I don't have my switches right? I do. This probably won't... This doesn't have enough power. Oh, it barely does. It actually gives a number there. 40. And this guy is on... He says 20. There's some voltage that should come through here, but it's not. How can I work my way up further? Yeah. Wow. Am I thinking this right, or should there be something down here? Because, wait a minute, I think I may have done this wrong. Let me just get back on the schematic here for a second. I think what are you doing, Shadow? He's looking for trouble. Okay, so the thing is, when we're using this, we're not tied into 2. 2 is 190. We're tied into number 5. Number 5 appears in the middle here. But there's actually wires on all these terminals heading into the selector switch. Maybe the selector switch isn't making contact. The voltage selector switch. The input voltage selector switch. If I wiggle that a bit, maybe things will come to life. But we should be actually looking between 5 and 1. Is that right? 1 and 5. I believe so. So we're going to move one lead. So 1, on this diagram, this is the lower one. This upper one is the one with the weird clip to it. You know what? That actually is the other way around. It depends. Yeah, the weird clip is coming to number 1. So the weird clip. Oh, look at this. Rose metal link fuse. There it is. I have found the fuse, and I think it is that weird clip. Rose metal. What? Rose metal link fuse. Never heard of it. Gotta stop and look into that. And try to figure out what the heck that is. Rose metal link fuse. Rose metal. You know, I have some fuse links that have a funny rose-colored metal on them. I wonder if that's the same thing. When all push buttons are up, set is in medium weight position. When medium weight button is depressed, its sole function is to turn the set on. When all push buttons are up, set is in medium wave. When medium wave button is depressed, its sole function is to turn the set on. Well, do these other buttons also turn it on? Or maybe we can figure it out from here. Oh, look. You even have to study this at length. These numbers must relate to the numbers down here. Oh, it's too soon for all that. I'm going to look into this rose metal fuse thing and find out what is that all about. Oh, I found this guy. Goodfellow, your global supplier of materials. Roses metal. Roses, not rose metal. Roses metal. And that's what it is. Lead, yeah, whatever. Material. We stock the following standard forms. We sell it in lumps. A lump. You need a lump? Common name, roses. General fusible alloy. Uses include anchoring, mold applications, and fusible links. Rose metal. Okay. Okay, so I just so I'm set to test a different wire here, but I just noticed that I had my meter on DC. That's not right. Now it's on AC. So we'll try this now. This is if this is set to 110, we should find a voltage here. We're all set to go. It should be there right now. No, it shouldn't. No. Okay, here we go. So I turn this up. This should go up. And it didn't. Okay, now I'm going to move this back to here. Still nothing. Nothing. So I'm going to take this wire. Now there could be, what, 20, not quite 40 volts there. Let me just turn this down while I do this here. I'm going to clip this onto the chassis and then go hunting. The other lead. Okay, a little bit of voltage here. No. Oh. Volt scale. My meter is acting up these days, so let's try it like this. Okay. Now that's only doesn't add up quite right. So here we're at 20 volts, and I make that out to be 0.6 volts. Is this definitely switched on? Yes. Let me switch it off. Oh, how did the voltage come from? I wasn't looking. Wait, what's happening? That's off. This would be on. So my meter, what is going on here? Let's use Old Faithful. Over here, never lies. AC. Never lies. At least I haven't caught any of his lies. Now, this is grounded. So the moment I put it on, the radio, which has been isolated completely, becomes grounded to the hydro power, just like anything, just like a 3-prong plug. We'll put it here, and we'll poke around and see what we can find. No reason to be nervous, Jim. Just put it on. Always nervous doing these things, because that's the moment you find out things aren't the way you thought they were. AC power. We're 15 volts, full scale. That should throw it right over if I hit the mark. It's a very, very low voltage there again. So I think if I'm here, what I should read is the supply voltage coming from here. We crank this up to 30 on this meter. 30 here. That gives him better, so that this guy needs a certain amount of voltage here to operate. Let's give him a little more. Okay. He's probably confused. So we'll break it and then give him another chance. Oh, you can't see what's happening at all. There. So we got 50 volts. So there should be 50 volts here, because I believe I'm just right across. It's definitely a 15 volt scale. Oh, jeepers, scare me. Where would the 50 volts go? That it's not making it all the way to here. If it was an open fuse, it'd be a 0. Something wrong with the primary windings on this transformer. Okay. Let's see if we can prove out something about the windings on this transformer. This is tricky again. These are very low resistance measurements and they're not easy to make accurately. But if there's an open circuit involved, that should be fairly obvious. Let me go back to this meter. Maybe not. Maybe not. You know what? I'm gonna keep you. I've never used the ohm meter. Let's check it out. Maybe the battery's dead. Oh, looks good. Pretty sure it's got to be like that. 0's good. Come on. Hey, how come we can't make it up there now? Up to infinity. 0's good. Maybe the battery's wearing out in this. It makes it, it's just really slow. We'll just give a little extra help here. Good enough. Now we're going to use this guy to try to measure the windings. So there's one end is here. Pretty sure this is one end. We're unplugged. This is one end. Oh, scare the heck out of me, phone. Now, we should read some resistances here. This is 1 ohm. Is that right? R times 1. No, it's direct reading. So 1 ohm is here. 2 ohms, 3 ohms. So that's reading as a... It's reading as a short circuit. Next one. Short circuit. So maybe I have this on the wrong spot. So we'll put this over here now. See if we can't read through the windings. Okay, that's a little different. No, it isn't. It's a 0. Why is this not working out at all? How do you get a 0 on all these things? I don't know what to make of all this. It's just zeros everywhere. The resistances were written on the schematic, and they're like 2 ohms, 3 ohms. 2 ohms or 3 ohms. Let's see if I can read 2 ohms or 3 ohms. some small capacitors here, or resistors here. Let's say I take this one. Brown, red, gold. What would that be? What? 1.2? This is a 1.2 ohm resistor. Trying it on this guy. We're checking the 0 first. The 0's on 0. You can't see it from there. Once again, even though it's not going to infinity, 0 hits the 0. What if we give it 1 ohm to work on here? Close to 0. Aha. He says aha like he's figured something out. How about a 3 ohm resistor? 3 ohms. That'd just make it worse. Well, so much for using this ohm meter. How about you? Yeah, on ohms. 3. Okay, let's try this meter now. Thought I was going to do better with the indicating meter, but obviously not. I'm going to use these short leads again. So we think the primary really can be checked by going there and going down here on the middle one. There we are. Now we got something. 14 ohms. That's something. And if I turn the set off, I don't think that should change. Now is 14 ohms correct? I really think I'm reading the primary winding that's being used by the radio. The 110 winding. 14 ohms. Okay, let's go look at the schematic. Here's the resistances here. And I'm guessing what they're saying is each of these windings is this amount. So if you're going to use from 1 up to 5, you're going to use these 3 sections. The 8, 10, 11.7. I'm counting these wrong. 7, 6, 5. So you go one more. So we count them again. 8, 10, 12. You add that, you get 15.1. That's roughly what we're measuring. 14 something. So this test suggests the primary is fine. Why no voltage getting into it? This rose metal fuse link. So I'm going to show you another kind of fuse that you find in these kinds of radios. So this is a fuse. It's also a resistor, 1500 ohms. And right here is some solder. And can you see that this piece is bowed up? That's because it's under spring tension. If I put a soldering iron on this, this piece will pop out. That's a fuse. That's a fuse. You can actually solder these back and close them up. These are commonly in high voltage circuits or in the speaker, or I'm not too sure what to say. They're associated with the output transformer. Let me say that. And but I don't think there's any in this radio. But that's an example of how things can be done. Is this another example of kind of a similar, solder it up, melt the solder, pop it open thing? There's a link under here. This is a link, and this is just the dumbest arrangement. I mean, there's nothing certain about any of that. So is that really the source of the break? So what I could do, maybe, I can clip down here. Well, you know, I can try. I can just try. I can try with some real test leads here and get rid of these ones for now. Is this thing continuous through here, or is it not? So we'll go up here, and first we'll test the meter. Hard to see for you, but then we'll come down here. So that's the horseshoe piece. It's definitely making contact. And now what's this piece right inside here? So I think this is all insulated down here. Maybe not right there. Yeah. Oh, not insulated. We get a 0. So it's continuous through here. Let's go right from the top right to what I think is the wire. Yeah. Whatever this is, it's conducting. It's just the weirdest thing. So what do we got here? Now we got a radio that's apparently not getting its AC to the primary. We got to assume it's in the wire here. Let's see if we can follow that wire again. Maybe there's an opportunity. So it goes in that hole. That hole there. So that hole is right inside this can. Let's look again. Let's take a real good look in that can this time. Lining the light up with it. There. So we can see the 2 power wires showing up. Then they're trimmed and connected. Are they? They appear to be going to terminals right in there. It's definitely what this metal can is. This metal can is protecting this connection. Look at how close that one is to the edge of the can. Oh, smokes. Maybe there's some cardboard inside the can? Yeah, they've got a cardboard piece right here. Inside the can. Smart guys. Okay, so from there, you know, could I check that the voltage is getting to the other end of the wire? Well, I think we can assume it is. From there, it looks like it follows terminals. It just goes in. It just goes in. Goes in where? Man. So there's 2 wires coming out of here. There's a yellow one and a brown one. What are they doing? So one of them, are they connected? No. So they're connected up at the top here. They have nothing to do with the power connections down further. You know, what we're left with now is there's a problem in the switch itself. The power switch contacts are not contacting. And where is that power switch? It kind of got me. In here somewhere. Sometimes they're on the end. They're in places they can be seen. Once in a while, the switch in this kind of radio is a regular toggle switch with a chain going to the top that pulls in two directions when you push the thing. An actual toggle switch. A discrete toggle switch. The broken string have somehow led to this problem. And by the way, the broken string here is metal. There is a metal wire flopping around in here. It's coming right into contact, almost into contact here. So this floppy metal string is a bit of a problem. I don't want to pull it out though, because I have to figure out where it goes after that. Son of a gun! Can't even get power into this radio. Well, what could we do next? So the power appears to not be getting here. I can't trace the wires back. They what? Assuming the black and gray wire are the what? Are the primary. This is the incoming primary. After the switch. It has to be a defective switch. So most of these contacts in here are switching. They're not switching 120 volt AC power. Whoops. They're switching something less, maybe some high voltage DC. If they were switching AC, they would really stand out. Hey, the schematic's going to help me with this. The schematic's going to tell me where the switch is. I think I stopped short because I got involved in this comment here. Wait a minute, this isn't the right thing. This is what we want here. Here's the pivot. This is that upper switch that only goes down when you push FM. Let's follow the power on this side. We'll follow the power here. So M1, M2. This is M2 over here. What's M? What's M stand for? Shouldn't it be S? So what are they saying? They're saying this and this slide up to connect the wires. They're calling it M2. They're calling this M1. M. And what are all these numbers? Just numbers on the switch terminals themselves. M2. Don't know what these M numbers are. They it's a fuse here, there's a switch here, there's some statement here. What are these M numbers? There's an M here. Hey, it says mains. It says mains. But we're way on the no. So in Europe or in England, mains means you're supplying to your house. This switch in any case is turning on this 230 volt source, which is off otherwise. Probably related to the FM or something like that. M2. Well, if this is push button number 2, push button number 1 is right at rose metal link. Fuse. Yeah, I was going to say, you would think they would picture this on here somehow. Is there some little thing I didn't read here? No. Numbers assigned to coil switches, plugs, sockets, and transformers are to facilitate circuit tracing or component replacement and may not necessarily be found on the unit. So we still don't know why they're using an M there. I mean, this is vacuum tube 9. There aren't 9 vacuum tubes in this radio. Vacuum tube 1, 1A, 1B. How do you get the 9? 1B, I don't know. Lots of mysteries when you first look at these schematics, or just what they're trying to show. Here's M2, this is M3. M2 is the PU button, M3 is the tape recorder button, M4 M2 does this. Is that what that is? Is that what, why would they? This is really not coming clear. See, they should put those M numbers down here if that's the case. If the case is they mean what I think they mean, I don't know what they mean. M. There, switch 2. What's the M2 for? Are those, when you push the button number 2, those are the switches you should be paying attention to? So the FM button, let's look at this question of when no buttons are depressed, the radio is off. Or when the off button is depressed, because the off button pops up all the rest. So you push any one button down, the locking bar goes into locking position, and that locking bar is probably what's turning a switch. And then every push button moves the locking bar into the switch on position. That's got to be how this is working. Hey, maybe there's more information to this radio. I don't have everything. Well, it's actually December 22nd. I've just finished editing or putting together the video you just watched. And it kind of ends suddenly because I just stopped working at that point. Never got back in my shop to continue the hunt for what is up with the on-off switch on this radio. So part of the reason I'm on here talking to you from the future past is because there's a little section in the video here where I'm doing some voltage tests using this meter, and I've got the ground, or the common connection, put on the chassis of this radio. That was a mistake. I shouldn't have done that. So those readings didn't really matter. You may have picked up on this. Not to worry. The thing about this work, what I find anyway, is that it's very iterative. You have to go over the same territory a number of times, and part of that results in cleaning out mistakes that you've made, misunderstandings, or conclusions that you reached you shouldn't have reached, and things like that. So this is a process of, say, every time you go through it, you get 80% good stuff and 20% nonsense into your head. Next time through, the 80% of the 20% is fixed, and you're only left with what? 6% nonsense. Once you get down to 1% nonsense, you seem pretty normal at that point. So anyway, thank you very much for watching. I'll be back in my shop tomorrow to carry on with this radio, and I have a few ideas about how to approach the situation with it. Don't know if they're any good yet. So have a great day.